The concept of altruism and acts of kindness may inspire a variety of both emotions and explanations. We may find it challenging to accurately predict what we or other people might do in situations that involve a range of altruistic acts. Altruism may be the thread that ties successful social groups together, but it is also complicated to explain. Psychologists generally define altruism as selfless behavior conducted on behalf of others without regard for one's own self-interest. Social psychologists' definitions include intentionality on the part of the altruist. In contrast, evolutionists define altruism purely in terms of the act performed, not the intention behind it. By these definitions, we can even see examples of apparent altruism in non-human animals. We can observe acts of self-sacrifice in soldier ants that don't get to breed themselves but defend the colony with their lives, and the worker ants that care for their younger siblings rather than having their own offspring. Wild dogs in Africa bring back meat from kills and regurgitate it to other members of their pack. Male Florida scrub jays help feed and defend nestling offspring which are not their own. Female dwarf mongooses suckle the young of other females, and mature female naked mole rats help to raise the young of the nest's queen rather than breed themselves. However, the explanation for why altruism occurs has long been an area of debate among evolutionists. But since the 1960s, there has been a growing consensus about why individuals of social species frequently do appear to act altruistically. Most recorded examples of self-sacrificing behavior involve giving aid to relatives with which the altruist shares a varying proportion of their genes. And this is true of all the examples in this table. In all these cases, it is now known that the individual who provides a benefit to others does so to its own relatives. Note that R, relatedness, which may vary from 0 to 1, equals the proportion of genes shared between two relatives by common descent. Full siblings, for example, share 50% of their genes with an R of 0.5, and identical twins share 100% with an R of 1. According to Hamilton's theory of kin altruism, we can expect actors to show self-sacrificing behavior for recipients when the cost to the actor is less than the benefit to the recipient. This has become known as Hamilton's rule and can be represented by the formula C is less than RB. Here, C is the cost to the actor, R is the coefficient of relatedness between the actor and the recipient, and B is the benefit to the recipient. Ultimately, these costs and benefits are measured in terms of inclusive fitness. Hamilton introduced the notion of kin altruism as an explanation of self-sacrificing behavior. And today we look at animals as inclusive fitness maximizers rather than simply as individual fitness maximizers. Modern-day evolutionists consider the genes which are passed on to the next generation through an individual's own offspring as their direct fitness, and those which are passed on through aid to other kin as their indirect fitness. This means that if a human being rears two children and helps other non-descendant kin, then they are boosting both their direct and indirect fitness. For worker ants and most naked mole rats, the only way they may be able to raise their fitness will be indirectly through providing care for younger kin and not offspring. Taken together, direct and indirect fitness equal inclusive fitness. In this way, Hamilton argued that we can predict that animals are likely to provide care for others who share genes with them by common descent, and that the amount of care given will increase, as does the proportion of these genes shared. But why did Hamilton add by common descent to his explanation of kin altruism? Members of a population may share the majority of their genes without being closely related. Siblings may share 99% of their basic types of genes with each other and with other members of their species. They will, however, share only 50% on average from their common parentage with exact matching alleles. In this way, R, the coefficient of relatedness, can be thought of as the probability that an allele shared by two individuals is descended from the same ancestral gene in a recent common relative. If an individual shows altruism to those that share the same gene by common descent, rather than those that share the gene simply by being members of the same population, it is this strategy that evolutionists consider will be favored by natural selection, since it acts on specific phenotypes of common descent. J.B.S. Haldane developed this theory during the 1930s, scribbling the idea on the back of a napkin in a London pub, that he would risk his life for at least an identical twin or 8 cousins. Under natural conditions, it is nearly always immature animals which are in greater need of aid than their mature relatives. For this reason, we can expect the giving of aid to younger, more vulnerable individuals by their older or less vulnerable relatives to be widespread in the animal kingdom. Here's an example of allomothering, with an older chimp taking care of an unrelated chimp's young offspring, giving it a ride on its back. If most cases of altruism involve acts between relatives so that those involved are helping copies of their own genes to be passed on indirectly, then is such behavior really altruistic? To most social psychologists, altruism is concerned with a willingness to help others at a cost to oneself. If we consider proximate, self-sacrificing behavior from a traditional human individual perspective, then we can certainly term beneficial acts to others, being relatives or not, as altruism. But social scientists interested in evolutionary explanations, considering ultimate causation, look at causation on a generational timescale. Ultimate causation is concerned with the likelihood of copies of genes being passed on. So acts that aid copies of shared genes in relatives are ultimately selfish. Thus, whether we consider an act as altruistic or not depends on whether we are discussing it at a proximate or an ultimate level of causation. Therefore, a beneficial act towards a relative is altruistic when considered at an individual proximate level. But when using a gene-focused or ultimate level of explanation, then the very same act may be considered as selfish. For most social scientists, the idea that animals help their kin in the interest of shared genes by common descent is not controversial. However, applying the same reasoning to our own species has led to heated debates. On one side of the debate, some social scientists argue that due to our intelligence and complex culture, our self-sacrificing behavior is free from genetic influence. On the other side, evolutionary psychologists hold that any genetically influenced responses which habitually lowered inclusive fitness, such as laying down one's life for complete strangers, would be likely to be removed from the population long ago. How likely is it that a person would willingly and altruistically sacrifice their own life for someone they are not related to, don't know, and are even prejudiced against? What psychological experiences, evolutionary adaptations, physiological factors, or other experimental variables might provoke such behavior? Trigger warning for situations involving violence and racism.